So let's fix our camera. Let's get rid of the cinema scene references. We might use it for basic, maybe some cinematics, but nothing else, to be honest. And yeah, okay. Let's get rid of all of it. Okay, we don't want camera, and we have our actual camera. So the way we are always doing it is finding an empty object, which is going to be your camera holder. Inside that we have the pivot, which is going to be rotating around, which can be about this side, or actually I think this is a nice position for, or well, the Y of the camera is actually pretty good, so I'm just going to set the pivot to be at that high. Oh, that's too high. What on earth? Okay, that's weird. You have your camera look target. Yeah, I think the camera look target is actually the correct position for the pivot. Yeah, okay, it was locally anyway. So let's set this to 0 and let's raise the pivot to be at what we want. I think for sols it should be something like this, and then we can make the camera go in and out depending on what you want to do. So this is our camera holder. Then let's make a new script which is going to say camera manager, and open it up. And we're going to be handling the tick for the camera ourselves. Float delta. Okay, we need of course the transform, the target to follow. And we also need to be passing mouse X and mouse Y. Okay, obviously. But for now we're just going to focus on this. So we also need to have public float speed or follow speed. And I'm just going to set it at 0.1f. And then we're going to be finding the target position. Transform.position by target transform.position. Or target transform, not target position, target transform.position, and all that by delta subdivide by follow speed. And that, of course, because we're using transforms, I'm just going to say on start, assign me the M transform, just so that we have the shortcut and it's faster. And then M transform.position will be target position. Come on. Target position. Okay, camera manager will only have one. So we could make this, actually no, let's not do that. Let's just go into the input manager. For now we're just going to drag and drop it. Camera manager. And yeah, it's a different namespace. Okay, and I think we also have the, yeah, okay, we get it from the cam main transform. Okay, anyway, so we have our movement execution order for handle movement. You can actually delete this because we know if we want to be moving on move update, and we're going to rename this to camera movement. Okay, and delete this as well. So we have fixed update and update. All we have to be doing is camera manager.tick time.fix delta time, and then mouse X and mouse Y should be class variables as well. Okay, so delete those. So let's put this inside update as well. But just for testing, let's also add this for late update. Do we have late update here? We do not. Let's write it out. Okay. And of course, late update has the same delta time as the update. And hit play. And we forgot to assign the script and drag and drop it. Camera manager and then input manager, drop it here. Hit play. And we forgot to also assign the target. We can do this on start, and we can say after we need, we can say camera manager dot target transform will be controller dot or just transform, I guess. So let's give it a shot. Okay, so now we have a camera that actually is following us. It is following in fixed update, but it doesn't make a lot of difference at the moment because we are updating in fixed update and we're actually not rotating. Actually, you can see the difference. It does. In update, you get all this choppiness, but in fixed update, it's working fine. Late update, we still have choppiness. So because we are moving with a fixed update, we're also going to be following with fixed update. Okay, awesome. That's also a way to debug problems like that. Okay, now let's do our camera. For our camera, we know that the Y or the look angle, let's also add a public float rotate speed or rotate speed. Let's go one by one. It's going to be handled by mouse Y is upwards, mouse X. So look angle by mouse X, mouse X, multiplied by look angle, not look angle, rotates multiplied by delta subdivide by rotate speed. That's the one we want. Okay, and that is our look angle. What do we do with the look angle? We're going to create an Euler with that. Vector 3 Euler. Vector 3.0, then Euler.y will be your look angle. Then that's going to be quaternion Esler or target rotation, and that will be Euler with the Euler, and then M transform dot rotation will be your target rotation. Now, why this works? Because we have the delta here. Okay, we can hardcode the target rotation here, so the values will be sort of lerped. It's not actually an interpolation. We just add on the look angle, and based on that we move around. Let's hit play. Okay, it's just too slow. So let's do 0.2. And we're actually broken this. Let's actually do 0.6. I think 6 is going to be too slow either. Yeah, 0.6 is way too low. Yeah, okay. Now the problem is that because it is a mouse, it has to be, it's an additive operation. So let's do by rotate speed by delta. Yeah, that's too fast. Okay, 0.2. Let's close the gizmos just to notice if there is any twitching. Okay, there isn't. Maybe it's kind of too fast. So let's say 0.5. Of course, feel free to change this to whatever value you feel it's necessary. Yeah, maybe that's too... let's do 0.9. Or even 1, I guess. Let's do 1.5. .5 is probably too fast. Let's see, 0.1. 0.1 is a slow one. Okay. So 0.1. Okay. So I think that's fine. Now, however, I kind of want to decouple my rotation from my movement. So I'm going to make this to follow target, and I'm going to make another one public void for handle rotation. Float delta, and we're actually going to be passing these two as well. Okay, for this now it's not needed, and we're just going to copy this and paste them down here. So I think follow target with fixed update, it's exactly working it works as expected, which means we can go back to the input manager and say that follow target now, we know it's working and we don't really care for this to be inside let update, to be honest. So let's comment this out. Inside update, we're going to keep this. No, we're not going to keep this. We're going to make this handle rotation exactly as it is. And in fixed update, we're going to duplicate this, cut this, paste it in here. We know it's working properly inside fixed update. We don't want neither of this, because you can see we have the same variable 2 times. We can make this here. Here and then here, and then here we're going to be saying handle rotation. Okay, I have a hunch that rotation should be inside update, but I might be wrong, so we'll see. Now back to the input manager. I'm going to set this to update instead. And that's of course too fast. Let's set this to 0.1. Now keep in mind that, yeah, now we're getting a nice behavior. Now we're getting the behavior we actually want. Okay, so camera rotation is going to be set at update instead of fixed update. So let's bring our pivot into this as well. So camera manager, handle rotation, okay. Float pivot angle equals nothing. Then pivot angle down here, mouse Y by rotate speed. If you want, decouple this as well by delta, and then Euler, I think the X is the pivot angle, and there we go. But of course it needs to be clamped, otherwise you're rotating everywhere, obviously, and it needs to be the opposite. So, or well, depending on your controls. So pivot angle can just be minus, and we can have public float mean angle or mean pivot minus 35, and max pivot as 35 as 35. Okay, then your pivot angle will be math f dot clamp between mean pivot, max pivot. Pivot angle. And there we go. We have rotation up and down. I think the speed needs to be decoupled from the rotate speed. So the rotate speed will, this one is going to be horizontal or look speed, and this will be pivot speed. And let's change the values. With 0.1 f this was working fine, but I think this is way too fast, so we're going to change that to something less. Awesome. So let's continue. And now we're talking, now we have a proper camera. But there's still one major issue with a camera, well, not major issue, one more feature. We need to know that if this is locked, none of this is actually going to be working. So if is locked equals false, or better yet, if not is locked, else. Now if you're not locked, you're going to have a target, public transform, so lock target. We're going to assign this, for now we're going to just hook it ourselves. Okay, so if lock target equals null, we're going to force is locked to be false. But if it's not, then we need to find our direction, and that will be direction, and that will be your lock target dot position minus our own position mTransform dot position, direction dot y minus equals what? 0, yeah, okay. And then dir dot normalize, then take all of that, Euler, instead of Euler, look rotation on that direction, okay, and it's going to clamp directly onto that. And then the smoothing of this for the frames will depend on how the other character is going to be moving, so this should be working fine. Okay, and actually let's not pass is locked, let's do it like this, and let's say lock target if lock target is null, otherwise. For now, this will save us a bit of time to not just pass it. Okay, so this will handle the position, but we still need to find the pivot angle for that, which means pivot angle, and yeah, that will give you the first direction for your own, and then we need the direction for the pivot angle. This one is actually wrong. Target rotation Euler, this needs to be separated because we want to be rotating the pivot, not our camera. So public transfer pivot. So pivot, okay, Euler. So let's rename this to Euler look, and that will be done above, okay. And then vector 3 pivot, Euler pivot 3.0, Euler pivot dot x equals pivot angle, then quaternion target rotation, target, or actually we can just use the same variable, doesn't matter, Euler pivot, and then pivot transform, or just pivot, I guess, dot rotation will be the target rotation, and I guess this can be Euler, and Euler, and Euler. So all of them are using the same variable. Not that it matters that much, but whatever. So okay, so right now we're going to have direction there, and then pivot direction. It's going to be lock target dot position minus the pivot dot position. Now normalize that, and y is going to stay like that, but x and z is going to stay like that. Also, this needs to be local rotation. Okay, then quaternion, or the target rotation, can now be look rotation as pivot direction, which, yeah, okay, let's use the same variable, whatever. Pivot rotation, there's no pivot rotation, direction, then pivot dot local rotation will be target rotation, but pivot angle for this is going to now be the pivot dot local Euler angles dot x, and look angle is going to be pivot dot not pivot, mTransform dot Euler angles dot y. Okay, so when we're getting out of the lock, we're going to have the same values and it's not going to clamp back. So save that. Let's create a target object. The player is not going to be doing much or anything based on that. Okay. And we need to set the pivot. We can take the transform. And then for now, I'm just going to drag and drop the lock target. Or actually, let's not drop the lock target. Let's hit play first. Okay. Now it's working fine. And now let's drop the lock target. And I think it's cube 4. No, it's not. Okay, so let's debug this. So this now is actually looking downwards because we are using the lock target dot position direction Z transfer dot position target rotation. So giving us the top rotation minus pivot position. Oh yeah, I think and this is actually wrong. The pivot only moves on the X. So that means dir Z, oh no, it's not moving on the X. So you know what, let's just leave the pivot as it is. And it's just going to rotate to where it has to. So let's try that again. And drag and drop the cube. This is actually wrong as well. So the camera holder is actually looking correct. Okay, that's fine. The pivot is not looking correct because it's looking straight down for whatever reason. And let's see why. We have our lock targeted position minus our pivot position. We normalize that and we're closing this too. Yeah, I thought I'd fix that anyway. So let's comment those two out and let's see what that's going to happen. That's what's going to do. Lock target. Okay. Here's the thing though. Under pivot, we now have rotation on the Y, which is whatever. We want the Y to be 0 and it's going to be looking dead on there. Okay, so dir.y equals 0 for that. And I think Z, it's not the Z is going to be the tilt, so yeah, it's not going to be, we're not going to have any problems. Okay, oh damn it. Yeah, just fix that. Okay, so here's what we're going to do. Instead of saying target rotation, we're actually going to leave this as it is. It's going to find the correct rotation, the correct direction for you. Then the target local rotation, we're going to take that and turn it into an Euler from target rotation dot Euler. Okay, then E dot Y is going to be 0. Then local rotation is going to be, well, I think not local, just the rotation or the Euler angles, just going to be E. Let's try local Euler angles first. However, which also means this is the, oh, okay, yeah, okay. Let's drag and drop the cube right away. So I want to select the pivot and see where it's aiming. And voila, that's the way to do it. And I think that's the target we're going to keep. I always thought that there was a midpoint where you were actually looking in sols, but I guess not. That's how you do it. Okay, so moving in and out, that should work. Awesome, so now we also have a lock camera. The only thing that we are missing from our lock camera is the velocity. Basically recentering the velocity or towards where we are going. And that can be fixed with public float. Let's say reset speed. Let's say 0. Then on handle rotation, on lock target, instead of saying the lock angle should be target rotation, target rotation, then our rotation will be that. Then on top of that, we're going to basically add mTransform.rotation, quaternion, slerp, target or target transform dot rotation. That will be our second. That will be our first rotation by delta by reset speed. Okay, and the reset speed is just going to be something really high, because it's a fraction of a second. And of course, no, actually let's just keep it. It's basically going to be recentering. So let's remove the cube. Oh, you know what? It shouldn't be done like that. It should be done differently. It should be done. We have a target rotation. We want the Euler of that. Vector 3, reset Euler. And that will be mTransform dot Euler angles. And then the look angle is going to be a simple lerp between the look angle and the reset Euler dot y. Hit play. So once we are unlocked, let's see, let's actually do a debug. Look angle is 50. Yeah, we need to also fix the root motion. So we have our camera. Let's say not pivot speed, reset speed, let's set it to 1. No. Look angle, reset Euler y. Player controller dot Euler is at 3. Because we are adding on that, then we should be look angle. Yeah, the look angle is actually I think if we move this above here, then it should be doing something. Let's ignore the lock target, and then on the camera holder, on the reset speed, let's say 1, so you take 1 second. and you don't do anything actually. Huh, that's interesting. But I don't understand why. Reset Euler's I, delta speed. Yeah, by reset speed. That's weird. That's very weird. So let's attach this here. Attach that. Okay. So we're here. Look angle starts as 145. We don't care. Reset Euler. The reset Euler is our target, which now gives us 145. That's the same. That's the same. That actually does nothing. 93, 93, 3. Does nothing, but we're oh. Yeah, okay. We have the M transform, not the target transform. Okay, then let's just put that back down. And now it should be resetting. Yeah, my bad. Okay, of course that's way too fast, way too much. So let's set this reset speed to 8 or whatever. So now when you are moving, let's do even higher. Ah, okay. Yeah, maybe even high. That's actually recenter, not going toward or not rotating towards where we're moving at. So I guess here's what we can do for that. Let's just say reset speed, set it to 200. Okay, and let's forget about it. Then let's say pass me the horizontal or float horizontal. I guess we only want to know the move amount for this, and on look angle subdivide by that. Let's say also add plus move amount by something, by velocity speed, public float vel speed, and don't know, let's say 0.1 or even slower, I guess. And then for handle rotation you have all that. For move amount now I actually wanted to do, let's make this here float move amount so that we can have and pass it here, but I think we can take it from I guess not. And in handle input we have vertical and horizontal. Move amount then is going to be mathf.abs vertical plus mathf.abs horizontal, and all that mathf.clamp 0 to 1. Okay, we just need to have a value that you are moving. We don't really care how much you're moving. That's why we're clamping that. And also our rotate direction should be normalized at some point. Movement direction, this gives us a row, so movement direction dot normalize. So we're not moving faster when we're going left and right. Okay, so let's see how fast we're going to be affecting our speed depending on our velocity. That's too fast. Let's say 1. That's way even more faster. 1 and let's remove the reset speed or reset speed. Oh, it's additive. And it's actually going opposite. So let's do this. Or this can just be on itself. And then for look angle. Oh yeah, if we have move amount, that's just always positive. So we want to pass horizontal and vertical as well. No, that's terrible. Anyway, you know what? Screw that. We'll find a solution to that out some other time. Then just go on the input manager. Let's fix the error and we're done with this part as well. And we now have a working controller that we can move around, we can rotate, we can do a lot of things. Okay, and then a little too slow, but with some movement, with some patience, I guess. Okay, it will actually reset and go to have the same rotation as this guy, but I think that's kind of terrible because it rotates. So if this stays at 0, yeah, it's not going opposite or negative. So you know what? Let's leave out the reset for now as well. Because it's opposite and negative. So we don't want that. Anyway. Maybe we'll fix the... Yeah, okay. There is another way we can do that. Sort of similar. Okay. Just for completeness sake, let's try it. Let's try and do it. Instead of doing this, we're going to do quaternion, reset rotation, and that will be quaternion slerp m transform dot rotation to target transform dot rotation. Okay, then t will be delta by reset speed, and then your look angle will be reset rotation dot Euler dot y, and we can delete that. And that should do, you know, that should cover all of it. Yeah, so any speed it can be positive or negative, it won't matter. Okay, so let's set this to 1. It will reset to that position. Of course, we kind of probably want something like 50 or 100, I guess. It will find the fastest speed and it will rotate. Let's set this to 1. So when you're moving there, okay, so I'm going to just leave it at 30 and call it a day. So that's it for this part. As always, you know what to do. Like, subscribe, and if you like to see more of this, which I'm sure you do, then consider supporting me on Patreon so we can keep making a lot more of this and actually turn it into a game. I have a couple of surprises for you for this series, but I'm going to let you find it out later. Okay, so the next part we're going to fix root motion problems, and we're going to see what else we can add to that. So as always, you know what to do. Like, subscribe, and if you like to see more stuff, feel free to support me so we can keep making those. I'll see you next time.